Welcome to our third and final installment of our curriculum videos. So now I'm going to talk about, well, just to recap, we just went through modules and how to build a structured sequence of students learning the background concepts needed. These are your in-classroom lessons that you'll be guiding students through in order to learn the concepts that they need in order to complete a project. So before I show you how this works in app, let me show you. So before our app existed, this is an example of a project starter. So this is our water quality project starter. And in this project, students will investigate the quality of local water sources by collecting and analyzing samples. They'll observe the environmental factors at the sampling sites. They'll measure nutrient and heavy metal concentrations, and they'll use different tools to visualize their findings. So they'll learn some environmental science, some field observations, some chemical testing, and some data visualization tools. So we break down the different competencies that are kind of built during these projects. So this is building some field sampling skills. So students will be collecting water samples safely and systematically by recording site observations. They'll use water quality test strips to analyze concentrations of different elements, and they'll be recording this data. So they'll learn how to create a data table, take notes, fill in information. And then with this specific project, students are using Python, a coding tool, to create a map that communicates water quality findings. There'll be many opportunities throughout the year for you to learn and implement different coding practices into your classroom. However, you could also create a physical map. For example, if you're one of our art teachers, this would be a great project for representing data science in a artistic and engaging manner. So students are collecting different water samples, they're analyzing them. How can they create an art piece that's communicating where local water quality sources are high quality and where they're maybe lower quality? And that kind of ties in with the science communication. So they're exploring multiple ways to present and share their results. And then it breaks down the project activities. So they're conducting the background research. So review what nitrates and nitrites, heavy metals are, why they matter, their possible sources, checking to see if there's local water quality concerns, something like that. Then the students will set their research questions. So this is where you can provide this maybe for your younger students, but for your older students, you might want to give them a little bit more freedom and flexibility in setting these research questions. This is very guided in these project activities. So the students will then select their sampling sites. So they'll pick different areas around New Hanover County where they want to collect the water. And they'll record the GPS coordinates at each site. Record field observations. It's walking them through step by step exactly what to do. This specific project comes with a digital spreadsheet to record this data. This spreadsheet is what's used to create the map in Python. So our Python code guide for this, it's important that this is not really changed at all. However, if you're doing this, making a physical map or doing something else with this data, you can customize this to fit your needs. So you get the idea. It's setting the specific project activities or the steps in order to complete this, and then kind of giving them the information that they need and how to actually complete it. And then some tips for success, right? So samples need to be in clean containers. Make sure that they're labeled and organized. Take multiple readings, right? We like to do multiple trials. Double check latitude and longitude entries, right? These are potential pitfalls that students might run into. So our in-app version of this is in the TeachSTEM dashboard, and it's in our project planning resources, and this is our project starter builder. So you'll see those sections here. So we'll have our title, our project overview, and these are the competencies, right? So this is where they're doing, if I can spell field collection techniques, right? That's happening here. So this is what students will gain from this. And then these are these major steps, right? So this is where I would be putting in these project activities. So the first thing would be conduct background research. So I would go ahead and I'd say, okay, this is where they're going to be conducting their background research. And this is where I'm going to add then those little details, those guidances, those specific questions I want students to complete will go in the subtask details here. So you can go through and add step by step what students will need to do to complete their project, and it will guide them through the whole process. Like I said, this is a very guided project here that we're designing. If you have older students where you feel like they can kind of take the reins with some experimental design, that's fine. You can customize this. One of your steps could be design your experiment. However, if you have younger students and you want them to follow a more guided step-by-step experiment that you have pre-designed, you would build it here into these subtask details where they would complete specific steps. So this is our project starter builder. So this is what students would complete at the end of a module. So to review the entire flow of a YSA project, we kind of start with the larger planning process. So thinking about what it is that our students are going to need to understand before they actually start their project. From this list, we go through and we design the lessons that will actually help them learn the background concepts. We then sequence those lessons into a module that students will complete in order to learn all of the concepts that they need. And then from there, the students will complete a project or a guided project that will actually help them apply the knowledge that they've learned through the guided lessons. So like I said, in all of this, we have resources here for you to implement these projects. You will have bi-weekly meetings with Ashton Carruthers, our TeachSTEM project coordinator. She is incredibly gifted at curriculum brainstorming and breaking down larger ideas, not just with science subjects, but she has worked with our English teachers. She's worked with social studies teachers. She's worked with teachers across the board in how to design some of these STEM research projects that support other curriculum standards. We'll work with you in actually designing the lessons within the lesson library and connecting you with all of the resources that you will need in order to complete these lessons and these projects. So at the completion of this video, we are going to ask that you go into your TeachSTEM dashboard and that you start completing the different tasks that you see assigned to you, and you start your first project topic brainstorm. So in order to move on to the next section of training, you will need to complete just one project topic and submit that for review. Now, some teachers already have an idea of the 4 projects that they want to complete and have already taken the next steps and submitted multiple project topics. If you are ready for that, go ahead. But to complete this first phase of training, all you need to do is start brainstorming your first project and fill out the project topic form and submit for review. And just to clarify, the project topic form is separate from the project starter builder. You do not need to complete that yet, just the project topic form. And then you will be all set for your curriculum needs.